kind introduction. So I suggest that we ask questions probably in the end, because I'm gonna pretty quickly try to pull you through all the things that BigVolumeBrowser can do. And you shouldn't worry. So the main idea now that you just take a look and get an idea what's going on. So it's all in the documentation. This presentation is in the data shared folder, so you can always access it later. Don't get stressed about anything. The main idea is just that you get what it can do and what the interface looks like. And then later we're going to try all the things. I'm going to be going relatively fast with a lot of info. But the main idea is just that you get what the thing can do. Plus, this is very first workshop for you and very first workshop for me, since the latest version was released just yesterday. And there are some new features that I really like and I want to show you. Okay, so we're just gonna go quickly through the installation, right? So this is FIJI plugin, you need to install FIJI, and then this is like standard update size if you know how to do it, and there is a entry for that BigVolumeViewer, so you need to check it. In principle, if you work with Zeiss files, CZL files, I also usually advise to install this Zeiss Quick Start Reader from Nicholas Chertin. It really helps to load things faster. And then you restart the FIJI, and basically you can run, it appears in the plugins menu, but you can also type here in the FIJI in the search menu. And when we're going to practice later, make sure it's the version 8. So this is the version like very recent. So then usually when it starts, you have a new window, which is called BigVolumeBrowser, and there are two parts. So left part is basically 3D canvas, and usually it will show some shader, like random shader. It's mostly like for the test, so don't be alarmed. And on the right, this is like a so-called cards panel. So this is basically user interface panel where you can navigate and adjust the objects and views and things like that. So one thing I really recommend you in the beginning is just to set up. So these things you need to do once. You just need to set up this plugin and kind of tell it what you expect from it. And you can do this by pressing F10, and then a new dialog appears shown here. And the most important parameter here is GPU cache size, right? So this plugin is made to work with 3D data visualization. So this is like naturally that we're going to be using GPU, graphic processing device, because this is the hardware that was made to work with 3D data. And in principle, BDV is really kind of hungry for resources like any other 3D processing. But this is kind of the cap that it can use the memory in the things, right? So usually I advise to put this value to like something around like 70–90% of your GPU memory card, right? And then you can say like, yeah, okay, but how much GPU memory do I have, and how do I know how much memory do I have? And since we live in the world of 2026, the answer to this question, you can just go and ask some large language model. That's probably going to be the best, because it will kind of try to navigate you and give you more precise answer given the characteristics of your PC. But in principle, there are usually two cases. One is when you have a dedicated special like buffed GPU, like NVIDIA or AMD Radeon or whatever people use for gaming. Then usually each card, when you buy it, it says like it has 16 gigabit of GPU or that much gigabit of GPU. Usually this value still can be expanded. You can still put higher value, because these cards, when they run out of this GPU memory, which is really fast, then they start to use RAM, but then things are much slower. So that's kind of a little bit of trade-off. And on the laptop, usually also it's like a little bit weird situation, but usually there is no clear GPU memory, but usually there is like a RAM thing that gets remapped. But in general, I must tell that if you're working with large data, which is like, more than 10 gigabytes, usually people use special dedicated PC or servers, and the data advised to be stored in SSD so it can be read fast, right? So in principle, as I like to think, right? So a lot of people say like, okay, BigVolumeBrowser is kind of Imaris for master students, or like, which is kind of partially true because it's comparable in the ways that it handles 3D data. But if you, for example, all these commercial packages for 3D visualization, right? Usually they go with a special dedicated PC. So they sell you the program and they sell you PC because they know that handling data in 3D requires a lot of processing power. In principle, there are some tips here. You can see your GPU parameters in Windows, and in Linux, you can use these things. But in idea, like you can try also experimental approach. So you put one value, then you see if it works, if there are some errors, and then you reduce the value. So in principle, the idea is that, right, we're going to work with 3D volumetric data coming from microscopy. And in principle, to visualize it in 3D, you want to load almost everything to the GPU memory. But if your data set is larger than available memory, right, then you will have probably very slow performance. It will be loaded only partially, so it's going to be like displayed only half of it, or BDV will crash with some kind of error, unless you use a multi-resolution file format. So this is kind of the main trick and this main reason why BigVolumeBrowser has big in the beginning, because it supports working with this type of file formats. And what is this type of formats? So if you have kind of raw data coming from your microscope, right? This is basically 3D stack. And this is usually how the software stores it. So multi-resolution file format, basically what it does, it takes this data and then it makes shrink down copies of that. That's the first thing. So this is why it's multi-resolution. And usually the original resolution is level 0. Then you reduce pixel size in X, Y, Z, right, by 2, and you make it smaller, and then you make it smaller, smaller, smaller. Plus what it additionally does, that it splits everything into chunks. So it never tries to load everything at once. It just loads only small things, and it knows where they are stored. And this is very advanced story. Why this advanced story? Because in reality, if you, for example, working with a data set around like really big data set, around 2 terabytes, right? And in this case, right, so like imagine these are the dimensions in X, Y, Z in pixels. In the end, your screen size where you're looking at it, right, has much lower resolution. So in principle, there is no point to load everything and sample all the pixels, because in the end, like, right, if we're looking at the whole volume, right, our pixels are much higher than the pixels of the dataset. So basically, if you're looking at the whole dataset, the view of the dataset, if we sample all the pixels, honestly, will be pretty much equal to the view if you load just 10 times those sample data, right? Just because of the screen size resolution. So from that point of view, there is no need to load all 2 terabytes. You can just load 2 gigabytes, right? And this is like specific resolution level, which is already in that file. But then at some point, if you start to again zoom in to some parts of this data set, right? Again, if you zoom into like 100%, in the end, you will see like just chunk of 1000 by 1000. So then still you need to load only some small part of this data set in the full resolution. Again, you don't need to load everything. So this is the main power kind of all this ecosystem of BigDataViewer and BigVolumeBrowser, that they know how to work with all these things, right? And basically, when you browse in your dataset, this BVV or all these browsers, they take care on what is it now should be loaded, what is the best resolution depending on how you look at it, and that allows you to browse really, really large data smoothly. Because you basically use much less memory. So storing the data in this format usually requires a little bit of overhead, but it's actually not that much. So for example, if you have indeed like 2 terabytes, so then if you store in this format, you will have 20% more. So but the user experience of browsing becomes really smooth. So practically, what are these formats? This is, of course, so there is its own format of BDV, HD file, so you can convert it using FIJI. There is instruction on the wiki, you can read about it, Imaris. So all these also commercial packages, usually what they do, if you try to open large data in them, they need to convert to their own format. And that's basically what they do. They basically start to build this resolution pyramid, right? There's Imaris, Aridis, all these guys work like in the same way. And alternatively, right, there is now a rise of OMSR formats, which are also pyramidal, also they store things like that. And in principle, BigVolumeViewer works with using the mobile plugin from Christian. We will talk about it a little bit later. But okay, but BigVolumeBrowser also supports small volumes, right? And regular volumes, so you can still use a BO format, so you can natively open files in the microscopy manufacturer format like Leaf or CZI, whatever you can open in FIJI, you can open in the BigVolumeBrowser. So that's usually what people start with. You need to, it's the volume browser. So let's add some volumes. And there are like 3 modes here. So left is like bioformats. The FIJI icon opens everything that is already, like if you have any windows in FIJI, and that is the last is the BigVolumeBrowser icon. So then it can load this multi-pyramidal XML, which again, I highly recommend you, if you have large data, just convert it to the ones and then use it for the visualization. So after you added the volume to the window, the bounding box for the volume appears. If you like it, you will already start to see something inside this bounding box. But if you're not like it, there would be just everything black. And that's usually because the brightness and contrast is not good. And this is kind of the same as in FIJI and image.sc, right? So sometimes you open images, they are dark. And then first thing you do, I don't know, like Ctrl-Shift-C, and then the brightness contrast, you click out and you see things. Not yet a feature here, so you have to drag the sliders manually. So any volumes that you add, they will appear in the sources panel on the right. And then for these volumes, you would have this slider of brightness and contrast. And if you use shortcut S, there will be a separate window where you can also adjust it, because like that one is a little bit smaller and that you can stretch. So in brightness and contrast, right, basically what it does, it basically maps the lookup table of the color to the values of your volume, right? And this is like happens from minimum value of the image values to the maximum value. And one thing that you need to be familiar if you're going to be using BigVolumeBrowser is these range sliders. They are used in a lot of interface, right? And these range sliders, basically, they specify 2 values, minimum and maximum. One is like larger than another one. Plus, usually the sliders on the right side, they have the range bounds, right? So this basically says like what is the length of this bar. And that thing you can usually change, right? So now you see the top slider is like from 0 to 130, but then once you found some value, right? And if the value is super short, in the user interface, it's going to be hard to adjust it precisely. So then when you adjust the range, it kind of snaps the length and you can do it like a little bit more precisely. So please kind of try to play with it, right? So this is, you can restore these bounds, you can shrink these bounds. So this is kind of one of the features that's going to be coming up over and over. So let's do that here, right? So we have this volume and we want to adjust brightness and contrast, and usually, right, you need to take the maximum knob and put it close to the minimum knob. And that's what I'm going to do now, right? I'm going to put it here. Oh, and something starts to appear around like 1000, but now these knobs are super close. So I'm going to shrink, right? And now you see the bounds up from 0 to 3000 inside of 65,000. And now I can adjust things much better. So this kind of first, the slider illustration, the second illustration is just like kind of how to find approximate rough range of the values in your image In principle, of course, you can open this image in FIJI, but not always it's possible. So this is kind of like a very quick adjustment of the thing. So now you start to see something. You already kind of, well, I'm already a little bit happy. So we will go a little bit through more precise adjustment in a second. But usually what you want to do is you want to change the color of the volume, right, or the source. And that can be done using all these squares. And if you left click on them, you can assign just a single color. So basically it makes single color lookup table, right? So then all the voxels will be painted with one color of different brightness. Or you can right click on that and then pick your famous FIJI lookup table that is currently installed, whatever you have, usually people use Fire or, yeah. Right, so it is a little bit hidden, not very trivial, but yeah, so there's like left, right click on these things. So once you're done with that, the colors are assigned, we already start to see something. The next kind of choice that usually people stand for is you need to pick the rendering mode. And BigVolumeBrowser supports 3 rendering modes. So this is, they can be found in the source render card panel, right on the right, this one. And there is a maximum intensity, volumetric, and the surface modes. Let's quickly go into what is different about them. So first thing, right, visually you already see, right? So kind of maximum intensity allows you to see through it. Volumetrics looks a little bit like it's opaque, and surface looks, right, like it's thresholded, which basically is true. So the way that this rendering engine works underneath, right, so we have our 3D volume made out of voxels, and then basically what it does, it has a camera, and then it shoots a lot of rays for each pixel of the image that we have, and then in the like virtual space, this ray traverses your volume, and then you have this kind of ray intensity profile. And the volume rendering is basically the type of volume rendering depends what you do with this ray intensity profile. And here I draw some arbitrary intensity, right? So this is like on the left, the red arrow is basically the ray, and intensity on the ray is shown on the right. So maximum intensity, what it does, basically it picks the maximum value, right? And from that point of view, it needs only one value, right? So you have the value of the maximum value along the ray inside your volume, and then you convert it into the color. This is pretty simple. So ray intensity profile is a little bit, volumetric mode of rendering is a little bit more complicated, right? So in volumetric mode, what you have is that each voxel has not only the color, but it has also an opacity, right? Which is kind of 1 minus transparency. Opacity is usually called alpha, right? So this is transparency. So basically then what happens is that when we walk along the ray, right, we can imagine that each voxel becomes some kind of cube, which can be transparent or opaque of different color. And then what this rendering engine does is just accumulates how light will be passing through this kind of medium, right? And we know from everyday life, if you put a lot of like semi-transparent objects, at some point you stop seeing through them, right? So then like this opacity kind of accumulates, and this creates this visual effect of real 3D objects. So this is what happens in volumetric thing. But the important thing to realize is that now, if before for maximum intensity projection, we mapped our voxel intensity values only to color, now we also need to map it, these values to opacity. So we need to say what we think opacity should be, or like transparency. And the last thing is the surface rendering. And in surface rendering, everything is relatively kind of simple. So basically, it's kind of a thresholding. So we go through this ray, and if we hit the thresholded value in the opacity channel, we say, okay, this is the end, this is the surface, and don't trace later, just stop and pick the color from like how we map the color. Right, so these are kind of 3 different things. So in principle, kind of the volumetric rendering includes both surface and maximum intensity, because it depends both on both kind of values, and the others one are two extremes. So now we need to use the opacity. So where is the opacity hidden? If you look at this brightness and contrast dialog, there is one bar with three angles, and usually it's hidden. You need to click it, and then the panel expands. So you can also map the alpha value or opacity value. So in the expanded state, what we have, the range slider at the top right is basically this color or lookup table mapping, or just classic FIJI brightness and contrast remapping of values into color. And then there is another slider. Well, you cannot see here, but it is like also a range slider where you can independently now map opacity, map your intensity to opacity, to the alpha or to transparency. Plus, there are two gamma sliders, right? So gamma, by default, both mappings happen linearly, but gamma allows you to do this non-linear mapping, which can really improve your features and really improve the appearance of the dataset, especially for 3D dataset. So let's just go back to our volume, and here you can see what I'm doing now. So I got really fine initial picture, but now the linear scaling does not work that well because you have these very bright pixels and very dim pictures. But if you change the gamma value, right, you start to map intensity a little bit non-linearly. So then these bright pixels, which are still the signal, dim pixels, which are still the signal, but they are like a little bit too dim for linear mapping, they start to appear in the view. And as you can see, there is also like a checkbox at the bottom. And this checkbox basically synchronizes the changes between the color mapping, so lookup table mapping, and opacity mapping. So now both of these mappings are the same, which is fine for maximum density projection. But if you want to go to the volumetric mode, we will have to change that. But even in the volumetric mode, it's nice to have this checkbox selected in the beginning, so you can kind of, like find the range, right? So if you have, so if your data set is loaded and the initial range is 65,000, but your data range is from 0 to 100, right? You just want to move all of them there. Okay, we go to volumetric mode. So again, we can switch for this source to the volumetric mode. And now you see that, of course, things become kind of volumetric, like the brick. So what I'm doing here, right, I'm actually reducing the opacity of the pixels with low intensity value without changing the colors, right? So as you see, like the two bottom sliders, they basically change what is visible, and they do not change the color of the voxels. And the top two sliders basically say like, okay, from what is visible, which colors we assign to them. So that's usually my algorithm, how I adjust the things. But as with anything in this life, in the end, the final result kind of depends on the person, right? So now you kind of get a general idea how to work with the things. And then there is no right or wrongs here, right? Everything is just like a representation of the data that you already have with specific mappings. So you can find kind of settings that work best for you. And then in the surface mode, right, the most important thing is the maximum of the alpha of the opacity, because that basically thresholds the whole volume and says where the surface is. And then the color of the surface, of course, is still regulated by the slider at the top. Right, so it looks a little bit similar to the volumetric mode, but in the volumetric mode, some things look like they are non-transparent, so they have opacity of 1. but some things can be transparent. In the surface mode, you have only opaque things that are rendered, so it's a little bit more restricted mode. But on the other hand, a lot of people like it because it looks like shiny, like a real object. And in this case, like, yeah, the gamma of alpha does not depend on, does not change anything because we're just interested in the thresholding. And the top guys are just mapping the color of the surface. So you can also change to lookup table, and then it will have multiple colors, etc. Okay, that was probably the hardest part of this presentation. And I want to congratulate you that you survived till so far and not a lot of people dropped out. Now we're going to go a little bit faster. Or slower. So apart from the rendering modes, you can also change the lighting. It's kind of fake lighting. I'm not going to show it here. You can just click it. So these lighting modes, they work mostly, not mostly, they work only for volumetric and surface rendering. You can just click and see how things change. So I'm not going to show this now. Last thing is that, right, so in the end, we render kind of continuous picture, but our data is voxelized. So sometimes this array that we use to find, to shoot through our volume can go through the values that are not at the centers of the voxel. So then we use different interpolation. And by default, so this like kind of trilinear interpolation makes data smooth, and nearest neighbor is more like each voxel really like looks like a voxel, right? So in principle, if you work with continuous microscopy data, continuous distribution of intensity, trilinear is the best. And nearest neighbor always going to look voxelated unless you're working with some kind of segmentations. And in segmentations, you actually don't want to do any interpolation, right? Because at the boundaries, right? So the segmentation data is where each cell, for example, right? The volume of each cell, voxels of each cell is mapped with one number, 1, 1, 1, 1, 1, right? And then next to it is like 10, 10, 10, 10, 10. So then, of course, the interpolation in between going to give you some kind of artifacts, because in between is going to be 5, which corresponds to another cell, etc. So in this case, you can use nearest neighbor. That's pretty much that. Okay, volumes are done. And what else can be loaded into this plugin? You can load meshes. So these are kind of surfaces with colors, 3D. And you can load point clouds. So meshes can be loaded in a variety of formats, right? So there is this list here. And actually, I like, I don't know, recently I played with this polycam, so you can use your mobile phone to scan any 3D objects. And you can actually scan your microscope and start your presentation with like 3D volume of the microscope. So that's now possible. So meshes you can render them differently, like a plain mesh. You can make it shaded, half transparent, shiny. You can build it as a grid if you're a fan of the Lawnmower movie. And it supports the meshes with texture, right? So meshes with texture is just not only surface, but there is some image projected on its surface, so then it looks much realistically. And these textured meshes also can be rendered in different modes, right? So in principle, right, these guys can be now added together and can be rendered next to the volume, right? So here we're looking at the expanded microtubules, and someone is hiding there. So this is basically the mesh which is exported from this Polycam program or from Blender. You can use anything. You can also use a point cloud. You can render a point cloud, and basically what is point cloud is a set of 3D points. So the input for the point cloud is usually just a text or CSV file where you have 3D coordinates, and it can be some time points. Each point can be a change in its position over time, right? Or it can have, so it can tracks, so it can change the size, it can change the colors. So practically, it can be, of course, the single molecule localization data, right? This is the super resolution technique where you have in the end, like the coordinates of the molecules. You can use it for anything special, transcriptomics, yeah, centers of cell, even in principle, like the leader thing. So you have this laser scanning thing. Again, I'm not going to be going in too much details. Hopefully the things in the documentation are explanatory, but basically this is like a little bit like Excel wizard, you know, when you like import things, it says like, yeah, what is what, show me. So this basically the interface, you just map, you say, okay, this column is X, this column is Y, and etc. And then you can look at the data, right? So this is time data, so this so-called attractor. It's like some solution of some differential equation, and on the left is just raw data kind of loaded. But what I show with the middle one is that you can map the lookup table and this fire lookup table into the speed of the particles, right? So here the particles which move faster, they are labeled with brighter shade of the color. And on the right, you can also map that value of the parameter not only to the speed, but also to the size of the particle. So it can be helpful for many applications. So if you have some property, you can later remap it. And of course, you can use it also for single molecule acquisition. So this is volumetric data. So this pre-acquisition for the 3D data. So this is like immune cell, and these are microtubules of immune cell, and this is one reconstruction. And in principle, you can use this to compare different reconstructions next to each other. Right. So this data set is something around 10 million points, and this is all rendered in my laptop, so it works pretty smoothly. And there is one data set also in example data where you can play with it and see how you adjust and play with things. And this is just like a nice example, because it turns out in Netherlands they have a public record. So they scanned the whole country with LiDARs at the 50 centimeter resolution. So anybody can go online and download. And then they did also the airplane color mapping to this data. So basically you have like a 3D point cloud data of the whole landscape of the Netherlands. And this is center of Utrecht. This is famous Dome Tower. If you want to visit some point, you will probably need to come and check it. Okay. So this is about adding objects, right? Now, once you added the objects, you actually want to navigate around the scene, and that can be pretty confusing because everything is in 3D, everything rotates, you don't know where you are. But basically, these are the standard things. So left mouse button gonna rotate things, and right mouse button gonna drag things, and then Control-Shift mouse wheel is gonna zoom in and out. In addition, there is this view card panel, which helps you to navigate how you look at the things. Mostly this is about the camera orientation around your scene. And the most important and my most favorite button here is this one. It's like center button. And that's whenever you're on the canvas, just press C. If you lost, press C, you know, like just, I cannot overemphasize how nice this button is. So what will happen if you press C? Basically, if you have some selected objects, it will just put it in the center, focus on it, put it in the center of your view and navigation. And this is what I'm showing here, right? So I'm selecting, so when you select an object, the bounding box around it becomes highlighted with the blue color in this case. And when I'm pressing C, basically it just snaps and becomes located in the center of the things. Alternatively, you can also rotate the scene view to specific planes, right? And these are the planes, so they're labeled by axis, and these axes, so if you press X, the X axis will look towards you. If you press Y, right, Y will look towards you, so you will see the XZ plane. So you can just click them and it helps the navigation. And in the last release, I honestly stole the navigation gizmo, which is shown on the right top corner of BigVolumeBrowser from the Blender, which is like, right, the free open source. So this basically helps you to orient the view to a very specific plane here. In principle, also, there are things to just rotate around different axes by 90 degrees. So these are these buttons. And whenever you have some objects loaded, then you spend like half an hour adjusting brightness and contrast, positioning everything, and then plugin crashes or electricity drops out or something, you know, like it's always kind of frustrating. So in principle, there are these two buttons which can save the state of the scene, so position of the camera, time point, everything, and state of all the objects. So all the properties of the objects will be dropped into a file that you can later load and apply. So one important thing for you to keep in mind is that for now, this functionality does not load the objects back. So it basically applies the settings to whatever is already there. So you will have to load objects manually. In principle, in the stored file, you can see what objects were there. But this is for now what it is. I think it's still pretty handy. So you can, whenever you work on something, you can load the data back, load the scene, and continue working pretty fast. So once you start to add multiple objects, right, you need to navigate this a little bit. So all the sources are living in the sources card table, right? So we were talking about this. All the shapes living in the shapes. So these are the meshes and point clouds. And then you have like all object list, which includes both of them, where you can select one or another one. And they also have these nice icons corresponding to like from whatever you loaded the things. And these selections are synchronized. So if you choose something in sources, it will be selected in all objects, and the other way around, and shapes is kind of the same story, right? So since you're going to be manipulating different objects, whatever you start to apply to an object, you need to select specific objects, and you can do it basically from from these panels, right? So here you see that I'm selecting corresponding entry in the list, and the box in the render becomes highlighted, right? So this is the head, fly brain, so there are two selected, and now like let's select also, probably going to be selected the rabbit, right? So this is kind of hopefully obvious, but sometimes you don't want to find the things in the list, right? So you just want to select something that you're already looking at. And from that point of view, you can also select object using canvas. So, and this is, since the left and right mouse button already reserved for things, we're going to use kind of the keyboard as a mouse button. And we're going to use the, for the specifically this selection, we're going to use the E button on the keyboard. So if you put the mouse over some object and you press the E key, it becomes selected. Right, so this is what is shown here, right? So E. And if you press Shift E, it will add to selection. And if you press Control E, it will toggle the selection. And if you click outside, it will remove all the selection. So this is pretty handy. The other story is that you can modify this object. We're going to talk about this in a little bit. So you can rotate them, for example, you can adjust them, and you can do that not only for the single objects, but if you selected multiple objects, you can still do that. But then it's a little bit confusing if one object is different, the property of some object is different, what the user interface should show. And this is what is shown here, right? So you see that these three rabbits, they all have different positions in space, right? So different coordinates, X, Y, Z. And so if we select one bunny, the center coordinates at the bottom, they display the coordinates, right? So this is at the 0, this one shifted a little bit in X, this one shifted in X and Y. But now if we select 2, right, one of the sliders becomes red. Red means that the values of the objects are not consistent, right? So user interface basically reflects the property of the objects, in this case, the coordinates of the meshes, rabbit meshes. It means that it's not consistent, but it doesn't do anything about it. As soon as you start to drag the slider, if you interact with the slider, it actually sets all the values to the current value of the slider. It is maybe a little bit not very trivial, but you can just try and play with it and see how it works. So in principle, one thing that you can do with object is each object that you load it, like is it a mesh or is it a volume or the point cloud, you can apply transformation to it. And usually these transformations, they are as you see, these are the sliders. So now, for example, is center or translation, right? And usually it is implied that the top one is X, the middle is Y, and the bottom is Z, and they also color-coded. And that's usually for all of the things. So this is basically the center of the objects, and here we have two of them, right? And we can translate them. So the translation can be, right, so this matter of the user interface. So you can either change translation if you're in the world coordinates. So there is like an extra icon here that now it's clicked, right? So in the world coordinate, basically you say, okay, this is the loaded volume, how much it is translated, or you can, instead, these sliders can show you the center of each of the volume, right? So these are kind of the local coordinates. And in principle, these crosses at the top right, they can always, if something goes wrong, you can always click them and everything going to be reset. And then also there is a rotation here. And again, in the local coordinate, if you apply some rotation, they will be rotated around their own center. And in the global, they will be rotated around the center of the view, right, in the world coordinate. So if you click it a little bit, maybe it's not so obvious now, but when you start to do things yourself, it's going to be a bit more clear. And in principle, it also supports slide sheet data, so you can basically disqueue the data that you have. If some of you work with that, that's pretty handy. There is a manual transform mode where if you press T, you enter this manual transform. And normally your navigation, you click in left and right mouse button, navigation changes the camera. So it moves all, well, it does not move object, it moves camera around them, right? But in this transform mode, depending on what is selected, I use it a lot. It's actually pretty handy because it's much easier visually move things rather than, like try to move the slider and find the proper position. So when you enter this mode, the camera is not changing, only the selected object orientation is changing. We're going to try that later too. The last part, not the last, but one of the last part is the clipping of the objects. So this is especially, in my opinion, handy for the datasets, especially for EM datasets, right? You want to look inside them for any kind of dataset. So basically, that's what this thing is done. You need to activate the clipping, and then there are two modes. One is when the things are inside the clipping cube, and one things could be outside the clipping cube. And basically, the range specifies the coordinates of this cube. Again, it can be done with respect to the original coordinate, right? So now they're both selected, and we in the local coordinate, in the object's coordinate space. So then all the clippings kind of move together. Or you can do it in the global system when both of them selected. So then it's going to be kind of one clipping cube for both of them, right? So different things require different applications, right? So there is maybe too much choice, but in principle, everything comes from experience. So you just start to play with it and then you figure out things. Okay, and this kind of clipping allows you to do this curtain effect that maybe I showed it already. And the trick here is that you have the same clipping object, there's the same clipping box for two objects, but so the dimensions of the box are the same, but for one object, the clipping is in the out mode, and for the other object, the clipping is in the in mode, right? So then basically they, they kind of complement each other, right? So where things are missing in one, they are present in another. That's why actually the clipping here, right? You see that it's it's marked as red. It's not consistent for these two objects. Okay. So finally, the last part is the animation. There is an animation panel, and it's made on the principle of the keyframe animation. So basically you have a timeline of the movie that you want to make, right? So here it's from 0 to 5 seconds. And then you say like, okay, you save this scene state, right? The state of the scene and of the objects, and this is one keyframe, and then you can add, you can change something, say, okay, this is another keyframe, and then what plugin does, it basically morphs one scene to another. So it interpolates all the properties going there, and that looks approximately like this. So here I added this camera orientation, these clip-in settings, right? So now I'm changing the clip-in settings, and I move the object. Now I'm going to the panel, and I say, okay, after 2 seconds, I want thing to look like this. I can click preview, and it right away morphs one thing to another. Right, so this is the way to do the movies, right? Basically, I don't know if you ever worked with any other packages, but it's very similar to the others. Apart from 3D script, where you need to type things, which is also pretty nice, but this is kind of the approach selected for these things, right? So later, this animation kind of storyline or timeline, right, can be saved and loaded. So you can, if you're not happy with something, you can edit it and re-render these things, right? And probably you guessed that the red button renders the movie. One thing is that, again, this save and load does not automatically load the objects, because in principle, these objects can be anywhere. It can be in the internet and things like that. It just applies the setting, right? So you need to load objects again yourself. So very quickly, we're probably going to do some animations. But my general advice, when people start to do 3D animations, they start to rotate things start to become like super 3D and everything. So my advice is just, you looked at this data probably for a very long time, you know how it looks, but for whoever you're doing movies going to be looking at it for the first time, so really do it slow and gradual. First show one thing, then like expand a little bit, wait 3 seconds, show another thing. So test it on maybe some of your family members for this, and avoid rapid, like fast turns of the camera and things like this, and add 3D captions. So there are a bunch of things online where you can just put text and it will give you a mesh with this text that you can add. You can make it appear, disappear. These are some of the free resources where you can do it. And just to give you an example of the bad movie, this is the movie that I made with the data that we have. So this is like so-called puzzle body, where we want to show different proteins in 3D, where we did mapping. And right, so there are a lot of things, not very clear what's going on, everything jumps. And once I had an error, made a mistake of showing this video in my talk on the second day of the conference. And on the first day of the conference, we had a big banquet with a dinner where a lot of beverages were consumed. So then I showed this thing first thing in the morning on a huge screen. So a lot of people became dizzy. So this is not a very good example. So this is the same data rendered by our talented PhD student later. And you can see that this is much more visually pleasant and nice, right? So things show slowly, appear slowly, everything is annotated, right? So you don't feel like something going on and I'm missing out on everything, right? Okay, so the other advice, I usually do like different parts of the movie like separately, so then you don't need to deal with super long timelines. And in the end, you can use some video editors for the final compositing of things. There are some free alternatives. Yeah, so this is the part where Christian comes. So this is which we did the integration of BigVolumeBrowser with Mobi. So Mobi, I hope some of you know and use it. You should. I don't see any excuses since you're in EMBL, right? It is amazing viewer for remote data sets, all modern formats, right? And you can really like align them, store the settings, and load a lot of different data from EM and the spatial transcriptomics. So basically now all these objects, almost all of them, you can add them to BigVolumeBrowser, and you can create the movies, animations, and renders of the scenes. And this is one of the recent things that, well, actually, it's also data from EMBL, right? I saw the truck that was assembling, it's in the window here, what is assembling the data, right? So this is expansion microscopy data of protists where, right, this team traveled around the world. And this is basically, again, this is on my laptop. This is just basically Mobi plus BigVolumeBrowser load, so I can look at this data already in 3D. And this is it's beautiful, right? So these microtubules, they're always nice. And you have these spiral structures over there. So now you can also, whatever you want, you can make a movie out of it. Okay. We are done. Final remarks. The plugin is version 8, so it's still in active development. I think the main things are there, but since it's in active development, there will be a lot of bugs. Please be patient and forgiving about it. From now on, it will only improve, hopefully, right? So I still realize how many things needs to be improved there, and hopefully they will be. So I also really appreciate any feedback and report issues. If you're using it and you get frustrated with something, don't just give up. At least write something to me in the image.sc forum or in the issues. And if you do have some nice movies, feel free to share with me or not. It's just up to you. Finally, I want to thank my bosses in Beach Labs. I'm working, and they allowed me to have some time to work on this kind of data. And of course, the plugin relies on a lot of other open source software, which makes it development very easy. And these are just some people that participated in that. And I want to, the list is completely not full, but I want to thank them for their attention. And that's pretty much that. And we're gonna move to
questions.
Yeah, right, yes.